Now we're going to take a look at a problem that really is going to cause us some problems, or at least is going to make us pause to reflect on what we've got to do. That would be these questions down along the bottom. Even number 9, 9, 10, 11, and 12. They're real head scratchers. All right, let's take a look at number 12. $676, and we want to add to that 24. All right. Now there is not a decimal point in either of these numbers, so we know that the decimal point is right after it. So line them up and then just do the addition. 6 and 4 is 10, carry the 1. 7 and 1 is 8, and then 2 more is 10 again, 0, carry the 1. 1 and 6 makes 7. So our answer is 700. Now that's what our calculator says, but where is the last significant digit in our answer? Well, written in this manner, the last sig dig is the only sig dig, and that's the 7. All right. All right. So the last and only sig dig, all right, is the 7. Now maybe that's okay. Let's go back, because what we want in our answer is to have its last significant digit in the same place value as the numbers up here, whose last sig dig is also in the hundreds place. But is that the case? Now, a quick look at it, and you're going to say, nope, it is not. Now, let's get rid of those. Where's the last sig dig in this top number, 676? Well, they're all non-zero, so they're all significant, and it's the 6, which is in the ones place. Number 24, same thing. They're all significant because they're all non-zeros. The last digit 4 is also in the ones place. So that has to be reflected down in my answer. Right? The answer here, 700, has to have its last sig dig in the ones place, not in the hundreds place. So therein lies our problem. How do we show, or how can we force these zeros to become significant? Because according to the rules, if you're minus a decimal point, trailing zeros are not significant. Well, the simplest thing to do is just throw in a decimal point. Right? Now, with a decimal point, trailing zeros are significant. So there you go. The answer would be 700 with a decimal point. Now, we typically don't write numbers like that in math or in any other situation where we deal with numbers. But here in chemistry, when we're doing sig digs, and you need to force certain digits, zeros, to be significant, that's one way of doing it. The more acceptable way to do it is to transform these numbers into numbers in scientific notation. The number 700 would be correctly written as 7 times 10 to the second power. We were going to move the decimal point 2 places that way. Now, we see that the way it's written here is there's only a 7 here, but I want this 0 to become significant. So I make it as part of the number, 7.00. Right. When we look at sig digs for numbers written in scientific notation, we don't look at the exponent part of the number. We just look at the mantissa, the front part. Right? If we were looking at the number 7.00 and following the sig dig rules, we would in fact say that all of these digits are significant. So the zeros, they're trailing zeros, but they're after a decimal point, so they are considered significant. Right? The second 0 after the 7 is now significant. All right. And if we go back up here and sort of just layer that on top of our original 700 number, these zeros are now significant, which means that we've accomplished what we wanted to, and that is that the second 0 after the 7 is significant. All right, so we've got, this is a possible answer, but the more acceptable answer is going to be 7.00 times 10 squared. Very confusing. All right, you're going to have to stop, really think about this, use your brains, turn on as much of your brain as you can, and just go back and look at the videos that I posted for you. Go back to that OpenStax online chemistry book and pull up that section on significant digits. And the Khan Academy material is also very good on this. I'll put a link down on this announcement, these videos, how or where you could go to this Khan Academy to look at this.